Hansen.
Thank you very much, Frederick. Now, I am incredibly happy that I'm doing this talk in English because otherwise none of you would understand a word I'm saying, and that doesn't matter if I'd done it in Swedish or in Danish, so you'd be equally confused all the way around. I have the unenviable pleasure of following Kevlin Henney, a man who I respect greatly, especially for his stagecraft. I mean, watching him present is fabulous every time. And I have to follow that up, so I have some bad news and I have some good news. Now, the bad news is that I am going to be giving a talk now on responsibility, and you're going to end up feeling a little bit depressed at the end of it. The good news is that there will be coffee and cake afterwards, so you'll get to enjoy that nice sugar rush before we go into the final two presentations of the day. So I'm hoping that'll sort of weigh up for it. The even better news is actually, since Kevlin Henney is here, then I can just skip doing my whole presentation because he summed it up in a tweet. Looks like this. For those who think programming equals writing code, just remember that driving is not just turning the wheel and pushing a pedal. And for me, that sort of sums what I want to say today, because really we have as a, well, I don't want to call it a profession because we're not. We are a job, an enterprise. Oh no, not enterprise, that's going to be wrong again. Let's call it an occupation. Because what is a profession? There's a fantastic definition I found, and I'd like to read it to you, and it goes like this. A profession arises when any trade or occupation transforms itself through the development of formal qualifications based upon education, apprenticeship, and examinations, the emergence of regulatory bodies with powers to admit and discipline members, and some degree of monopoly rights. We have none of that. Well, that's not entirely true. We have some of that. We do have ways to enter our organization. Now, this quote is courtesy of Alan Bullock and Stephen Trombley. And like I said, I find that it sums it up quite nicely for what is a profession. So, how do we become a developer? How do we have these rigorous standard ways of joining our occupation? Well, do we have the right way? We have the self-taught people. I'm guessing that there's at least one or two of you in here that have had more or less no formal education, but still managed to wander into this occupation anyway, and you are thriving in it. Is this the right way to enter our occupation? We have mentoring. Now, there's an area where we both succeed and fail miserably at the same time. We succeed because there are so many fantastic people in this industry who dedicate their time to teaching others in a variety of different ways, be it through talks or workshops or smaller courses, but it's usually tailored to the individual. Unfortunately, where we fail is that we don't have the standardized and rigorous process that we see in, for instance, carpenters or plumbers or these professions where you have the actual concept of apprenticeship. Somebody who can go in there, start to build and be taught in a rigorous and reproducible way. If you've ever had a mentor, you'll know that no two mentors are going to be alike. And again, this is a benefit and a weakness of our way of teaching people. We have a multitude of educations. And when I say a multitude, I mean everything from the 6-month program that'll guarantee you'll be the best developer in the world and make loads of money just as soon as you've paid them the obligatory $30,000 or whatever it is starting fee. We also have actual serious educations, ranging from 1 or 2 years and being often very practically focused, out to multi-year bachelor's and master's degrees where people end up being called engineers afterwards. I'll get to that in a moment. And then we have certifications, countless certifications. And the way I see it is that certifications in our industry are primarily good for answering one question, and that is, do you know how to take a test written by this specific organizer? Have any of you done a Microsoft certification ever? Fair few. Microsoft certifications generally work the way that you get a question, you get 4 choices, 2 of them are absolutely ridiculous, the other 2 are plausible, and they depend on a single keyword in the question. There you go. You don't even need to know any of the subjects, you just need to know that, and you can go in and you can ace most of their certifications. That isn't something that gives us a gold standard or a reproducible way of saying, I have taken this certification, I have this knowledge, you can rely on me to be able to do these things because I have proven it. That would be a good certification. Unfortunately, we don't have those. What we do have is we can now become certified Scrum Masters in 48 hours. Dan North has a fantastic rant on Twitter. I highly recommend looking it up. It's been going on the last couple of days where he's talking about the concept of Agile and Scrum and all of these areas. And really, look it up. It's worth it. Now, engineers. This is an engineer, Eisenbart Brunel. He has designed a lot of structures. He's a classical engineer, if we will. This is one of the things I think of when I hear the word engineer. I'm sorry, but I don't think of any of us. To me, engineer is a word that we have tried to appropriate in order to attain the gravitas of people like this, who are building things like this. This is the Clifton Suspension Bridge, which I suspect that Kevlin might know of it, considering that it's going from Clifton and Bristol to Leawood to North Somerset. And this is based on designs by previous Bromnell. Actually, when I think of engineers these days, I'm more inclined to think of this. A group of people who are sitting around working on some kind of architecture sketch or the similar, trying to figure out how to safely and securely build a new structure. And one of the things I also think about with engineers is that they have a responsibility, because if you are an engineer and you build something like this, then it needs to hold up. A lot of our systems don't need to hold up, and we have gotten quite used to that. We are fairly okay with having a system that fails in production. If this ever failed in production, then, well, it's going to be expensive to repair, that's one thing, and lives will be lost. And it's one of the topics that I'm going to keep revisiting is the concept of lives being lost, because we are moving as software developers more and more into the area where we can affect human lives. We can do it these days with medical devices or with cars, or it can even be something like thermostats that are internet connected. So, classically, people use to reference the 1968 NATO Conference. I don't know if you've heard about it. There might have been something previously about this. And the thing I've seen most often referenced is that this 1968 conference was a message to basically tell people in the software industry to shape the fuck up. We need to actually take on the mantle of engineers and become serious in our work. We need to be responsible about what we do, and we need to be able to reproduce it. And to that degree, I can somewhat like being called engineers. I'm still never going to have the title in any reasonable way myself. I do not have the education required for that. But I found an older reference, and it is one of the debatably oldest uses of the word software engineer. And it is the following from Anthony Oettinger. We must recognize ourselves, not necessarily all of us, and not necessarily any one of us all the time, as members of an engineering profession, be it hardware engineering or software engineering, a profession without artificial, irrelevant boundaries like that between scientific and business applications. Here we get into the definition that we are using engineer to remind ourselves that we are grounded in reality. We don't just get to write things on paper and say, well, this is a nice theory, we can talk about this for a couple of decades and see if we get anywhere. We have real world impact. Unfortunately, we sometimes forget that. So one of the key things that I want to get into as well is the concept of innovation versus regulation. Any of you heard of Bitcoin? Guessing one or two. I'm going to keep my summary of the technology short because, quite frankly, I'm not well versed enough in Bitcoin to go into all of the intricacies of it. But what I can tell you is, well, Bitcoin is a decentralized digital currency. It is dreamed up more or less entirely by software developers. It is heavily privacy focused. We really want to attain this freedom of, scrying eyes that are looking into our every transaction, being forced to have a bank that knows all about who we are and what we do with our money. And it wants to be free of national regulations. Now, freedom from regulation is fine if you're responsible enough to act with it. What we've seen with Bitcoin is that basically we have a group of people who are now trying to redo what banking in the modern world has been doing for the last centuries, and discovering that actually this is a bit harder than we thought, just building stuff. And it's also unfortunately been a prime reason why something like ransomware has been exploding in the last couple of years. Because here is a private, digital, untraceable currency. What's not to love for a criminal? Now, is this good or bad? Well, Bitcoin is really neither. Bitcoin is a tool, but there's definitely an argument for more oversight and more regulation that could potentially have been useful in helping stymie some of these developments. Or it could have completely killed off the project. It's kind of hard to say at the moment, and with Bitcoin fluctuating like it does, who knows if we'll see in a full-scale real-world adoption. We do see real-world use of it, but outside of the criminals, it's not as popular. This face may be familiar to a lot of you. This is Edward Snowden, who in 2013 became very, very infamous when he leaked a massive amount of data from the NSA. Now, Snowden and his whistleblowing is not really what I'm interested in here. What I'm interested in is the system, or one of the systems that he leaked information about. The system is called Prism. Now, Prism is operated by the NSA, and it is one of their main tools for gathering raw data for their analytical reports. This is an incredibly noble goal, trying to defend your nation from outside aggressors, wanting to ensure the safety of your population. And I'm pretty sure that's a lot of the arguments that were being used when this system was being built. We have to protect our country, we have to ensure that we can survive, we have to ensure we do not get attacked. I seem to remember something about Goering telling people that the easiest way to corral everyone is telling them they're being attacked. This might explain why we build systems like this. Prism basically listens to everything. It tries to key into more or less the entire backbone of the internet. And with this access, it correlates data and tries to make the raw data available, like I said, for analysts to look for patterns. There might even be some blink techniques involved there, just trying to find out if we've seen something valuable or not. Now, again, is this a good or a bad system? The system pulling in data in and of itself, there's nothing inherently evil in that. But somebody has gotten told to build a system where the purpose will be to spy on the world. Is this okay? Is this ethical? Was that question ever raised? And this is a thing we tend not to do in our industry, is raise the question of whether or not something should be built, or at least not publicly. Uber is another fantastic example. Now, in case there's anyone here who isn't familiar with Uber, Uber is essentially, they are a ride-sharing company. You use an app on your phone, you get call somebody up to you, and they get to play private taxi. There have been some legal issues. When I say some, I mean they've been banned in quite a few countries. There have been horrible cases of sexism and abuse inside their company and how they treat their employees, so on and so forth. But again, that's not even the interesting part about Uber. And to me, it's not the worst thing that they've done. Well, it's up there. No, the interesting thing for me is the system they built called Greyball. Greyball was built as a system to allow Uber to control which users use its ride-sharing features. So let's say that I have installed the app on my phone, and I open it up, and I close it, and I open it up, and I close it, and I never really do anything with the app. I never really order a ride from the app. Well, at some point, Uber is going to say that I'm not really an interesting customer, so they're going to down prioritize me. They might even go so far as to block me completely. However, the way they'll block me is by sending me fake data. They'll make it look like a ride is coming if I finally order one. They'll make it look like rides are going around town when really all it is fake GPS data. Now, for me as an individual, that might be annoying if I really wanted to use the service, but what if you're law enforcement, trying to stop drivers who are driving around being illegal taxis in your city or in your country? What if Uber has decided that anybody who works at a police precinct is within a geofenced area and therefore they are considered bad customers? Why do we build something like this? We know why it was built, of course. It was built in order for the company to avoid prosecution or avoid evidence gathering that could be used in a prosecution, and it was used to be able to control which customers they have. And it sort of leaves you with a bad taste in your mouth if you're the developer, or maybe it doesn't, but it would for me leave me with a bad taste in my mouth if I heard that the feature that we were just asked to build, well, the use is trying to avoid the company getting screwed legally. So what are the responsibilities of us as developers? When are we supposed to say no? Do we have any responsibilities at all? Is it basically just a question of us saying, well, yep, nope, I built it, tester tested it, it's all good? It's a question we don't ask. And it leads us to another question. Have you ever been jailed because of a bug? Any of you? No? Okay, I was guessing no. I've only actually found one case of a software developer being jailed because they built software. Now, there are plenty of cases of software developers who have defrauded their companies, who have stolen things or otherwise. Those cases are rife in the world, and they have been convicted accordingly. But that's usually on grounds of theft or espionage or other things we're used to. Meet this man. This is James Robert Liang. He's a software engineer. There's that word engineer again. He claimed that he blindly executed a misguided loyalty to his employer. That was the defense his attorney tried to use. The opposing counsel said that he was a pivotal figure in the development of the system. The system in question is the Volkswagen emissions scandal, the software being built into certain Volkswagen cars that allowed them to bypass emission tests. Therefore, basically when you hook the car up to an emissions test, it would detect that it's being tested, it would push out lower emissions, it would throttle itself in that way, and it was out on the road. Normally it would just pollute extra so you get all the lovely horsepower that you want. He's the only man I've found, and he got convicted to 3 years in prison. The maximum he could have gotten was 5, but since he made a bit of a deal with the prosecutor, then he was given only 3 years in prison. This is the only case so far, and the so far is important. Next question, have your bugs ever killed someone? Now I mentioned that, if the architects and the engineers designing the big Öresundsbridge, if they had caused a malfunction there, then it would cost not only a lot of money, but people would likely die. And this is the scenario we're moving ever closer to. We're seeing things like the 2014 Jeep Cherokee. This is one of the major incidents where it really got noticed in the wider press that, hey, our cars aren't actually that mechanical anymore, they're mostly computers. Your modern car is basically around 150, 200 individual microcomputers talking with each other over a message bus saying, hey, let's do this. Somebody's turning the wheel. That has no effect on a car. It's just sending a message through a computer system. And they discovered that, well, actually, we can use a flaw in the entertainment system to take control of the car while it's moving on, say, a freeway at high speed. If somebody can take over control over your car when you're going 110, or let's face it, a bit more, because, highways. If somebody can take control over your car at that moment and maybe make the car accelerate or brake or steer in a different direction, that's going to have potentially and likely lethal consequences. Now, nobody's been jailed because of this, because this was a so-called security exploit that security researchers found, and therefore it was deemed that, oh, well, the company couldn't really do anything about it before because they hadn't known, and they issued a fix, and so on and so forth. So nobody was held liable here, yet. Does anybody know what this is? No, that's an open road. According to Tesla, yeah, you are absolutely correct. This is the truck that a Tesla Model S didn't see when it came speeding down the road. Now, the driver didn't see it as well because he was busy watching a movie on his iPad, and he trusted the Tesla autopilot system. This is what his car looked like afterwards. He did not survive. Tesla was found not liable in this case because Tesla has clearly stated that their autopilot feature is an assistance system. It is a helpful guide when you're driving. It can help you stay in the correct lane, it can help you switch lanes, and it can help you keep the pace. It is not a replacement for a human driver. But Tesla is working on a fully autonomous version of their autopilot, and so are many other car manufacturers. We are coming ever closer to the day where this could happen because, well, we don't actually have a way of controlling our car, and a software developer forgot what a truck looks like when we're doing machine learning on a vision system. Or we have this, the St. Jude's medical pacemaker. These days, pacemakers are getting Wi-Fi connections implanted because we want to make it able to that when you get into the hospital, we can update your treatment routines and we can make sure that you are getting the most effective treatment from your pacemaker. Unfortunately, this specific pacemaker had a security issue, which enabled anyone to open the Wi-Fi connection and control the pacemaker. They could increase the pace, they could decrease the pace, they could switch it off completely. There are no known reports of this killing anyone because it was a research that was done before the product was released, but that's pure luck. And again, we're reaching the point where we're building more and more medical technology. We're building more and more things that are impacting people directly. And this was just a security flaw that nobody could have foreseen, and oh gosh darn it, how could we know such a thing would happen? This is the tracking point precision guided firearm, or rifle, if you want to be on that direction. They have a fantastic smart scope on these things that allows you to use a laser to paint a target, and then as long as you just move the dot within the correct point, then you can shoot and be guaranteed that you'll hit what you're aiming at. This has a Wi-Fi connection. Does anybody want to take a guess at what I'm going to say next? It got hacked. And what happened was that somebody found out, hey, we can connect to this thing via Wi-Fi and we can change what it's targeting. And if you aren't paying attention, then all you'll see is, oh no, you have to move the scope a bit to the left. And suddenly you're hitting something entirely different. Now, these are being sold for a variety of different things, hunting and whatnot. And since we've already had quite a few stories of hunting accidents, imagine what happens when we start getting these things involved. Or just in warfare. We build systems like this, and yet we end up having systems that aren't fully tested because, hey, well, we don't do the security part, we don't do the testing part, we do the code. Malware is a topic entirely of its own, and I want to cover it briefly because There's so much fun in that area. Now, malware in and of itself is basically a term for malicious code that gets executed on your system. This can be done either by tricking the user or by exploiting flaws in the system. And most of the flaws that get exploited in malware are actually a consequence of a software developer who forgot to do some input validation. Oh, we don't need to do a boundary check here. Nobody's ever going to overflow this 1024 character buffer. Well, they did. And now this machine has, it's been entirely encrypted and you have to pay this person money in order to unencrypt it. Well, that sucks if it's your home photos. It really sucks when it's a hospital and they suddenly can't access patient data or they can't roll out into an operating room because the computer telling us how it works is down. Where are our responsibilities in these things? Again, nobody has ever been jailed because of this. Well, actually, malware specifically has gotten a lot of people jailed. We know famous stories like Kevin Mitnick, the hacker in the 80s. But these people are never jailed because of the code they write. They're jailed because of the consequences of it. And it's usually a financial consequence. It's, hey, you damaged this computer system, this has a value of X dollars, therefore you are now liable for that. But we keep losing focus on who is responsible for the flaws being there in the first place. And like I said, nobody's been jailed because of it yet, except James Liang. So it's a question of how do we want to move forward from this? There's one thing that we definitely need to do, and that is we need to establish standards within our industry. We have some standards, but standards tend to be pretty limited to certain sections of our industry. Now, the ISO IEC Joint Technical Committee 1 Subcommittee 7, that's a mouthful, works to try and build more standards, to try and make sure that we have access to how do we reliably write software, what are routines that we can all agree on and use, but it's not there yet. And again, even when it is there, we don't adopt it because we don't have the formal education guiding us towards these things. We need to start looking into things like ethical guidelines. Now, we might not need ethical guidelines for everything, but we will need it for certain areas. And as we're seeing, we're getting more and more connected, and we need it in more and more areas. We need to figure out when is it relevant to stop and ask the question, who can be harmed by this product? Who can be harmed by this code, this feature? There are two organizations that have a certain amount of this already, and that's the Institute of Electrical and Electronics Engineers and the Association for Computing Machinery. Unfortunately, these are voluntary organizations. Nobody's forcing any of us to take an oath like some doctors do, or to pass a bar like lawyers do. Why not? Why are we allowed to shape the entire world without any consequences whatsoever? Because that is what we do. We have the power and at this point the opportunity to shape the entire world. We see it with things like Bitcoin, trying to create a new global currency. We see it with systems like Google, which is taking over how we find information. So why is none of us accountable for what we build? We need to step up and take responsibility. We need to know that we build things not in a vacuum, not all by itself. We have consequences to the things we build. And we need to start looking into the concept of setting legal precedences. Because if we don't, somebody else is going to do it for us. At some point, James Liang won't be the only case out there. What his employers tried to imply was that this was a rogue group of developers working on their own, just trying to repeatedly screw over the EPA. That was very close to becoming a clear precedent that said that, well, actually, the company heads can just blame it on the software developers. Because suddenly the software developers are a good scapegoat. Oh, it's those people in the corner. They do those things with computers. We have no idea what they did and how they did this. And we didn't stop to ask them. And they didn't tell us. Do we really want to end up in a situation where we are the scapegoats? I'm actually going to be kind to you all since I've been hammering on about responsibility and dreary things. And I'm going to end it here. And we're going to be able to get our coffee and our sugar a little bit earlier than planned. So I want to say thank you very much.